Artificial intelligence, or AI, is one of the most transformative technologies of our time. From personalized e commerce to self driving cars, from connected homes to digital assistants, you have very likely experienced or been impacted by AI already. When you complete a search online, scroll through your news or social media feeds, or find the next video to watch, computers are deciding what you see. Even those pesky advertisements about a topic you were just talking to a friend about. So, what exactly is AI? And what do we need to know to help us use this technology effectively? For our purposes, we define artificial intelligence as human created, machine based systems that simulate tasks that typically require human intelligence, including decision making, predictions, content generation, and recommendations. Now, you may find subtle differences in how AI is defined, particularly with a variety of applications of AI and its recent pace of development. This can make it difficult to not only understand it, but also makes it a challenge to regulate it. Let's dive deeper into the foundations of AI and demystify this important technology. Artificial intelligence emerged as a field of computer science in the 1950s at the Dartmouth Summer Research Project on Artificial Intelligence, sometimes known as the Dartmouth Conference, which is widely considered the seminal founding event for AI. In the early days, classical AI approaches used human programmed rules to complete tasks. Imagine a robot programmed to bake cookies. The robot follows a set of human programmed rules. It preheats the oven, mixes the ingredients, shapes the dough, bakes the cookies, and then lets them cool. The robot doesn't understand what cookies are, but can complete the task by strictly following these step-by-step instructions. This illustrates how early AI systems perform tasks using predefined rules set by humans. By the 1980s, a new form of artificial intelligence emerged: machine learning. Machine learning is a type of AI where computers learn to perform tasks by finding patterns in data instead of being explicitly programmed with specific instructions, such as the human programmed rules of classical AI. We'll dive into this slide a bit more ahead. But imagine teaching a computer to recognize pictures of dogs and mops, or ripe and unripe bananas, like in our challenge task. Instead of telling it all the rules that define a ripe banana or an unripe banana, you show it many pictures labeled as ripe or unripe. Over time, the computer learns the patterns that differentiate ripe from unripe and can then identify or classify new pictures on its own. As machine learning is growing, this is where we also first see AI integrated into education with the creation of intelligent tutoring systems such as Play-Doh and the Algebra Tutor. These systems demonstrated the potential for technology to support individualized learning, laying the groundwork for modern educational technologies used in our classrooms today. And by the way, if you've ever come across the term deep learning or a neural net,
A CPU is a neural net processor, a learning computer.
that's just an advanced machine learning technique inspired by how the human brain learns. It uses layers of artificial neurons to learn from data, recognize patterns, and make decisions, similar to how our brains process information. Or better yet, we should say it was inspired by how our brains process information. If you're interested in learning more, we've provided resources in the course resource document. Now we've reached the topic that is on everyone's mind: generative AI. Think ChatGPT, Gemini, DALL-E, and more. Generative AI is a type of artificial intelligence that can create or generate new content, such as images, text, music, or even videos, based on patterns it has learned from existing data. Instead of just recognizing or categorizing data, generative AI can produce original outputs. Sometimes I like to think of this in terms of improv. Imagine a musician improvising a new song. Just as generative AI creates content based on patterns it has learned, the musician draws on their own knowledge of music theory, previous songs they've heard or played, and their own creativity to produce a unique composition on the spot. They combine different elements like melody, harmony, and rhythm in novel ways, similar to how generative AI synthesizes learned patterns to create something new. Now, this example is not perfect, but at least it's a start. While this is an exciting time, AI is not perfect yet. And there are a number of important concerns with this new technology. For instance, it often lacks transparency and explainability, just like it may be difficult for the artist to clearly explain how they created their new song on the spot. These issues are important for building trust and maintaining accountability in AI systems. We'll dive more into these later on in this video. Finally, during the initial development of AI, researchers dreamed up that by the late 1970s, we would have artificial general intelligence, or AGI, a type of AI that possesses the ability to understand, learn, and apply knowledge across a wide range of tasks at a level comparable to an average human. Well, sorry to those guys, but we aren't even close to that now. However, you may hear the term AGI, and it is important to keep in mind. All right, we've thrown a lot of vocabulary at you, but how does any of this human-created computer intelligence work? I present a challenge. Can you identify which images are chihuahuas and which are blueberry muffins? What if your dog's name is Muffin? Oh boy. How about this song?
Bare necessities, the simple bare necessities. Forget about your worries and your strife.
Bear, B-E-A-R, sounds an awful lot like bear, B-A-R-E. If the computer only had the audio, what version would you choose? Well, I suppose it doesn't help when there's a bear, B-E-A-R, singing the song about bear, B-A-R-E, necessities. For a computer, both of these tasks are extremely difficult. Let's explore why. Here's our machine learning figure from before. Let's start with data. AI needs data, a lot of it. AI doesn't know anything to begin with, but it uses data or input to learn patterns and make decisions. Think of it as a little baby that's using their senses and bodies to learn about the world around them. What's yummy and maybe not so yummy. But AI is just a program. It's just a machine. It needs input that it can make sense of and identify patterns in. In other words, for a lot of input A, the AI will provide an output B. A common approach to this is called supervised learning. It's supervised because the data that the AI gets is labeled. Labeling is like teaching a student with flashcards that have questions on one side and answers on the other. For instance, all of the chihuahuas and muffins. The AI learns to make predictions or decisions by finding patterns between the labeled inputs of chihuahuas and muffins and their corresponding outputs. The more labeled examples it gets, the better it becomes at making accurate predictions on new and unseen data. But the key is the data. What happens if the AI only receives a small amount of data on chihuahuas, but a whole lot on blueberry muffins? Well, it might be likely that this cute little dog named Muffin will actually be identified as a muffin. And there are a lot of real world examples of supervised learning that you may have experienced today. Ever wonder how your email account filters spam emails? Emails are labeled as spam or not spam, and the new ones coming in, while the computer is predicting or identifying it as spam. Including Google's translator, for instance. If you want to translate from English to Spanish, it's using this machine learning technology to translate into the language of your choice. Or for speech recognition. In other words, it has audio data as input, and then it's outputting the text transcripts. So, after all, it is BARE, B-A-R-E. How about those social media advertisements? Well, with information about your likes, shopping, web history, your conversations on social media, and more, these companies are able to predict which advertisements may work best for you. Sometimes, maybe just a little bit too well. Which brings us back to ChatGPT. How is this working? Well, thanks to the internet, we have a ton of text data available that can be used by AI to learn about natural language. When the AI is given a sequence of words, it's predicting or outputting the next word. Think of it like a trained parrot acting as an improv partner in a yes and game. The AI, in this case, what is called a large language model, is understanding the current context and using probability to generate a meaningful, relevant response to build on the conversation. While these technologies have great potential, there are a number of issues that we need to consider. For instance, I asked the generative AI tool to illustrate AI working as a co-pilot supporting a teacher, and this is what came out. And this was also after I requested a more diverse classroom setting. There's still a lot of work to be done. We're continuing to learn the true impact of AI. In the news, we have seen cases of bias identified in its output. If we are attempting to personalize learning opportunities for all students, what happens if we do not provide the personalized learning AI tools with sufficient data on all of our students? Coinciding with that, AI systems often require large amounts of data, raising concerns about how personal information is collected, stored, and used. Ensuring the privacy and security of individuals' data is critical to prevent misuse and protect against breaching. The new generative AI tools have also brought up issues of copyright, likeness, and more that we're still understanding how we can effectively manage. Moreover, we don't truly know the real impacts on using all of this computing power on the environment. We are now beginning to understand the impact of the tremendous increase in AI usage, and the environmental footprint of AI must be considered. With efforts to develop more energy efficient models and utilize renewable energy sources to mitigate negative effects on the planet. We're only beginning to understand the impact of such increased technology usage. It is important for everyone to be a part of the conversation and understanding AI's impact and how we can work together to minimize concerns and maximize the potential positive benefits. There we have it. As we've seen, AI is transforming the world around us, from recognizing patterns in vast amounts of data to creating original content and even engaging in meaningful conversations. Whether it's understanding the basics of machine learning or seeing how generative AI can create new and exciting content, the possibilities are endless. We're excited to embark on this journey with you to learn more about AI and discover how we can leverage its power in the classroom safely and securely to enhance education and inspire our students. Let's dive into the worlds of AI and unlock its potential together.